Section 2, Arithmetic Sequences and Series. A sequence in which the difference between successive terms is constant is called an arithmetic sequence. The constant is called the common difference, D. The nth term of an arithmetic sequence can be found by the equation a sub n equals a1 plus n minus 1 times d. So I can use this equation to find any term in the sequence as long as I know the first term in the sequence, the term that I'm solving for, which is n, and d, the common difference. So in example 1, it says to find the common difference in the next three terms in the sequence. So kind of like we did in section 1, we want to figure out what's happening to go from term to term. Since these are arithmetic sequences, then we're always going to be adding or subtracting the same number for arithmetic. So to go from 17 to 12, I would have to subtract 5. And again, from 12 to 7, I would subtract 5. So like we did in section 1, to continue the sequence, we'll just continue subtracting 5. So 7 minus 5 is negative, or 2. 2 minus 5 is negative 3, and 3 minus 5, or negative 3 minus 5 would be negative 8. The common difference is negative 5. That's the number that you're adding or subtracting each time, and then you can continue the pattern. Example 2 says to find the explicit formula and the recursive formula. So before we figure out what those two formulas are, we need to find the common difference between these numbers. So from 12 to 21, we would add 9, and again, 21 plus 9 will equal 30. So the common difference is 9 for this sequence. So we're going to start with the explicit formula. So the explicit formula is an equation that can be used to find any term in the sequence. So for an arithmetic sequence, the formula for explicit is a sub n equals a1 plus n minus 1 times d. So I'm going to plug in the information that I know. I want to plug in the first term in the sequence, which is a1, and the common difference 9 in for d. Everything else is going to stay the same, and then we're going to simplify it as much as possible. So I would have a sub n equals 12 plus n minus 1 times 9. So we're going to distribute the 9 in the parenthesis. That would be 12 plus 9n minus 9. Then if I combine like terms, the equation would be a sub n equals 9n plus 3. So the explicit formula would allow me to find the 15th term in the sequence. I could plug in 15 for n, and that would give me that value. Or the 500th term in the sequence. I plug in 500 and I find that value. The other type of formula that we're going to write is the recursive formula. So here's the equation or the information that we need for a recursive formula. You have to know the first term, so that's a sub 1. And then your formula is going to be a sub n equals a sub n minus 1 plus d. Okay, so we're going to write the first term of the sequence, which is 12. You always have to know where the sequence starts. So we're going to write a1 equals 12. Then for the recursive formula, the only thing that we're going to put in the formula is the d, the common difference. So a sub n equals a sub n minus 1 plus 9. So the purpose of a recursive formula is if I know the previous term in the sequence, I can get the next term in the sequence. So I have to know that the first term is 12, and then we would add 9 to get the next term in the sequence. So if I wanted to know the 51st term in the sequence, I would have to know the 50th term first. So the recursive form is good if you know the preceding term. You can find the next term by adding the common difference. But it's not helpful if you're just supposed to find a random number in the sequence. The explicit formula is more helpful for that. Okay, so in example 3, it says to find the common difference in the term name. So we need to figure out the pattern here, what we are adding or subtracting each time. So 25 minus 8 is 17, and 17 minus 8 is 9. So my common difference is negative 8. So I'm going to use that in the first term to write the equation for the explicit formula. So a sub n would equal 25, which is the first term in the sequence, plus n minus 1 times negative 8, which is the common difference. So we're going to simplify this, and then I'm trying to find the 68th term in the sequence, so I would plug in 68 for n. So if I distribute the negative 8, that would give me 25 minus 8n plus 8. Then if I combine like terms, a sub n would equal negative 8n plus 33. So now that I have the explicit formula, I'm going to plug in 68 for n. So the 68th term is going to equal negative 8 times 68 plus 33. So I get that the 68th term is negative 511. So with the explicit formula, it's easy to plug in whatever term number you want and find that exact value. If I had the recursive formula, I would have to find all of the terms before the 68th term, or at least the 67th term, in order to find the 68th term. If two non-consecutive terms of an arithmetic sequence are known, the terms in between them can be calculated. These are called arithmetic means. What this is talking about is if I know some numbers in a sequence, but I'm missing some numbers in the middle, I can use the arithmetic sequence rules and the common difference to help me fill in those middle terms. So in example 4, I've been given 4.3 is the first term and 12.8 is the fifth term. So I'm going to go ahead and label those A1 and A5. We're supposed to find the missing terms in the sequence. So I'm going to use the formula, the explicit formula for an arithmetic sequence. I'm going to plug in the information that I know. So I know that the fifth term in the sequence is 12.8, and that is equal to the first term in the sequence, 4.3, plus 5 minus 1 times the common difference. And there's a 5 in there for n because we knew the fifth term was 12.8. So if I can simplify this and solve for the common difference, then I can go back in and find those missing terms. So if I simplify on the right-hand side, 12.8 is going to equal 4.3 plus 4d. I would subtract 4.3 on both sides. So 12.8 minus 4.3 is 8.5. Then I would divide by 4 on both sides. And it turns out that the common difference is 2.125. So now that I know the common difference, I can take that and I can add it to the first term and continue that pattern to fill in those next three blanks. So 4.3 plus 2.125 is 6.425. Then I continue to add 2.125, and the third term would be 8.55. I add again, and the fourth term would be 10.675. So you use that explicit formula to plug in the information that you know, and you can solve for the common difference and then fill in the sequence. The first differences of a sequence are formed by subtracting each term from its successive term. If the first differences are the same, the sequence is arithmetic and can be modeled by a linear function. So that's what the sequences we've been doing so far are, all arithmetic sequences, because the first differences were exactly the same. Consecutive first differences may be subtracted one from another, producing second differences. If the second differences are constant, then the sequence can be modeled by a quadratic function. So we'll talk more about those quadratic functions in another section. So an arithmetic series is the indicated sum of the terms of an arithmetic sequence. So we can use these two formulas to find the sum of a finite arithmetic series. So remember, a finite series means a certain number of numbers in a sequence, not an infinite amount, but a countable amount. So depending on the information that you're given determines which of these formulas you're going to use. So the first one, S sub n equals n over 2 times a1 plus an. So if you know the first term in the sequence and the nth term in the sequence, then you can plug those in and find the sum of that series. If you are given the first term and the common difference and how many terms you want to add up, then you'll use the second formula. S sub n equals n over 2 times 2 times a1 plus n minus 1 times d. So it depends on what information you're given, which formula we will use. So in example 5, it says to evaluate the series, we are given the first term in the sequence is 5, the nth term in the sequence is 317, and n represents 47. So that means the 47th term in this sequence is 317. So we're going to use the first formula for the sum of a series. S sub n equals n over 2 times a1 plus an. So we're going to plug in the information that we're given. S sub 47, since we're trying to find the sum of the first 47 terms, equals 47 over 2 times 5 plus 317. So if you just type that in your calculator, it turns out that S sub 47 is 7,567. So if I was to figure out what the common difference was between this sequence of numbers, and if I listed out all of those terms from the first term, which is 5, all the way to the 47th term, which is 317, and I add those all up, it would give me 7,567. Same thing for the last example, number 6, we're going to evaluate the series. This time we're given the first term is 27, the common difference is negative 13, and n equals 28. So we're looking at the sum of the first 28 terms of this sequence. The first term is 27, and then the terms are decreasing by negative 13 every time. So we're going to use the second series formula. S sub n equals n over 2 times 2 times a1 plus n minus 1 times d. So we're going to plug in the information we're given. So that's going to be S sub 28 equals 28 over 2 times 2 times 27 plus 28 minus 1 times negative 13. So you might be careful if you try to type this all in at one time. You can simplify little pieces and then type it in would probably make it easier. So once you simplify, the sum of the first 28 terms of this sequence is negative 4,158.